Patients with diabetes often experience numerous problems related to nerve damage, impacting both their ability to see measurements on the insulin pens, as well as their ability to induce sustained force to inject the insulin. Our team was tasked with creating an attachment that does three things. First, it reduces the force needed to inject the insulin. Second, it communicates dosage successfully to the patient. And third, it communicates something called the prime test, which is basically a 2-unit test dosage that tells the patient whether or not the pen is working. In addressing these design blocks, our team has created 2 different solutions for force reduction for user preference, with a lever and a clamp. We've also created a magnifying glass attachment to address the issue of communicating dosage, and for prime testing, we will use pH paper.
Our lever mechanism consists of an 8.75-inch lever with an internal slit, which accounts for the changes in the dial height and to make sure that the lever comes into contact with the back of the insulin pen at all times. It also includes a 3.5-inch handle, as you can see here, and a snap-on piece lined with rubber in order to gain traction with the pen and to make sure that the pen will not slide up and down easily. And lastly, it also includes the electrical tape indicator to instruct the patients how to use this mechanism correctly. The snap-on piece and the lever are both made up of PLA material and are fitted together by a nut and a screw mechanism. Patients would first have to dial up the back of the insulin pen like this. We'll use 4 milliliters for demonstration and attach the insulin pen onto the snap-on piece like this. Next, the patients will rotate the lever so that it comes into contact with the back of the insulin pen, and when they're ready, they can take the cap off of the insulin pen and then inject into this squishy right here and use the principle of mechanical advantage to apply force onto the back of the insulin pen. The clamp is a modification of the 4.5-inch Irwin quick grip mechanism. It includes an 8-inch metal rod as well as a PLA snap-on piece, as you can see here, lined with rubber to prevent the sliding of the insulin pen. After the patient has set their dosage, they can attach an insulin pen to the snap-on piece like this. And then the patient can move the quick grip by pressing the little lever right here and moving it down like this so that it comes to contact with the back of the insulin pen. And when the patient is ready, they can remove the cap piece off and inject into the body. On to communicating dosage, we have the magnifying glass design. As you can see here, the magnifying glass is a 4.5-inch diameter, 10 times magnifying glass, attached to a ring that we 3D printed. Our 3D printed design also includes a PLA snap-on piece, as shown here, in which the pen can easily fit into. And we also have an adjustable 4-bar linkage, as shown here, to accommodate for a variety of vision problems. The insulin pen is ready for use. Then the patient can put the insulin pen onto the snap-on piece like this. And then the patient can dial up the back of the insulin pen. As you can see here, the magnifying glass will magnify the little glass box inside the insulin pen, and the patient will be able to tell the milliliters that they dialed. For the force reduction, both of the designs reduce the force it takes to press down on the back of the insulin pen very well, with the clamp being the slightly better one, reducing the force up to 75%. For portability, the lever had a slight advantage due to its ability to rotate and it being able to fold it in a shape like this, and this will help fit into patients' purses or pockets. And for adaptability, both of the designs work really well for a variety of pens, so these 2 designs are very adaptable. For communication of dosage, the magnifying glass successfully magnified the number in the little box on the insulin pen, which makes it easier for the patients to see the number of milliliters they set their dosage to. And for the communication of prime test, the insulin successfully turned the pH paper red, which indicates that it is successful. Communication of dosage. The magnifying glass worked as it magnified the number in the little box in the insulin pen and made it so much easier for the patients to read the dosage. For portability, the magnifying glass is very portable, as you can see here. When you compress this, it turns into a little nice rectangular box, and patients can fit it in their pockets or in their purses. And for adaptability, we're still working on that, but in theory, the magnifying glass holder will fit a variety of different pens. For tasks, we want to debulk both of these 2 designs. While both of these 2 designs work very well, they can be really heavy and gigantic, which makes it hard for patients to carry around. So for the lever design, we may potentially want to shorten the length of the lever. And for the clamp design, we want to replace the long metal rod with maybe like a plastic rod or a rod of lighter material. Next, instead of testing with random patients or random people on the eQuad, we actually want to test these 2 prototypes with patients, diabetic patients with neuropathy and retinopathy in live hospitals. And we also want to make sure that the attachment of the insulin pen onto the snap-on is easier for patients as well. And lastly, we want to improve the dosage communication. Instead of using the bulky magnifying glass like this, we want to maybe develop an electrical or optical reader for the patients.